Your fat cells are throwing a party right now, and you weren't invited. Every single day, while you sit there doom scrolling, your fat cells are hoarding energy, getting bigger, and basically acting like that roommate who never pays rent but takes up all the fridge space. But here's the thing, a simple 30-minute walk triggers a molecular war inside your body that your fat cells absolutely cannot win. And by the end of this video, you'll understand exactly why walking might be the most underrated fat loss weapon on the planet, backed by studies showing it can reduce dangerous belly fat by 26%, even when the scale doesn't budge. Let's get into the cellular chaos. So the moment you start walking, your body sends out an APB to your fat cells. Your sympathetic nervous system, that's your fight or flight system, releases norepinephrine and epinephrine. Think of these as eviction notices for stored fat. These hormones land on your fat cells like SWAT teams at the door. They bind to something called beta-adrenergic receptors on the surface of your adipocytes. That's the fancy science word for fat cells. And when they bind, oh boy, the dominoes start falling. First, an enzyme called adenylyl cyclase converts ATP into cyclic AMP. Cyclic AMP then activates protein kinase A, or pKa. And pKa is basically the project manager of fat destruction. It phosphorylates, which just means it activates, two critical targets. Target 1 is hormone-sensitive lipase, or HSL. Target 2 is a protein called paralipin. Now, here's where it gets interesting. Paralipin is like a bouncer protecting your fat stores. Under normal conditions, it keeps another protein called CGI58 locked away from the fat-burning enzymes. But when pKa phosphorylates paralipin, the bouncer steps aside. CGI58 gets released and immediately activates ATGL, adipose triglyceride lipase, the rate-limiting enzyme for fat breakdown. This kicks off a three-step demolition process. Step 1. ATGL cracks open the triglyceride molecule and pulls off the first fatty acid. Now you've got a diacylglycerol. Step 2. HSL, remember our friend hormone-sensitive lipase? Swoops in with 10 times higher specificity for this molecule and yanks off the second fatty acid. Step 3. Monoglyceride lipase finishes the job, releasing the third fatty acid and glycerol. Together, ATGL and HSL account for more than 95% of total fat breakdown in your white adipose tissue. That's not a typo, 95%. The freed fatty acids then bind to transport proteins, cross the cell membrane, hitch a ride on albumin in your bloodstream, and travel to your working muscles where they get burned for fuel. All of this triggered by walking. But here's why walking is actually superior to that HIIT class you've been dreading. There's this concept in exercise science called fat max. It's the exercise intensity where your body burns the maximum amount of fat per minute. And guess where it sits? At about 60 to 70% of your maximum heart rate. That's brisk walking territory. At this intensity, 65 to 75% of the calories you burn come directly from fat. Compare that to high-intensity exercise where only 10 to 20% comes from fat. The rest is carbohydrates. Why? Because carbs can be mobilized faster. Your body reaches for the quick fuel when you're sprinting. But when you're walking, your metabolism stays firmly in fat-burning mode. Research shows fat oxidation during walking reaches 0.65 grams per minute, actually 28 to 38% higher than cycling at the same intensity because you're recruiting more muscle mass. A 30-minute brisk walk oxidizes 8 to 10 grams of pure fat in untrained individuals and up to 15 grams if you're moderately fit. And before you say, but HIIT burns more total calories, a 2023 meta-analysis of 11 randomized controlled trials found no significant difference in body fat percentage reduction between high-intensity interval training and continuous moderate exercise like walking. Same fat loss, way less suffering. I know which one I'm picking. Now, let's talk hormones, because this is where walking really flexes. During exercise, insulin levels drop. This matters because insulin is the most potent anti-lipolytic hormone in your body. When insulin is high, your fat cells literally cannot release fatty acids efficiently. It's like trying to drain a bathtub with the faucet still running. Insulin suppresses fat breakdown through multiple mechanisms. It degrades that cyclic AMP we talked about and shuts down the whole pKa cascade. Walking's gentle reduction in insulin removes this metabolic break. But here's walking's secret superpower: cortisol. A study by Hill and colleagues measured cortisol responses across different exercise intensities. At 40% VO2 max, easy walking, cortisol barely budged, plus 5.7%. At 60% VO2 max, cortisol jumped 39.9%. At 80% VO2 max, that's your intense workout zone, cortisol spiked 83.1%. Why does this matter? Chronic cortisol elevation drives visceral fat accumulation. It increases lipoprotein lipase activity, the enzyme that pulls fatty acids into fat cells, by up to 9.4-fold when combined with insulin. And it specifically decreases hormone-sensitive lipase activity in abdominal fat, making belly fat harder to mobilize. Walking stays safely below the cortisol threshold. You're burning fat without triggering the stress hormone that wants to store more of it. Now here's where things get really wild. Your fat cells don't just shrink when you walk consistently. They transform their internal machinery. A University of Michigan study found that 12 weeks of moderate intensity exercise produced smaller fat cells, increased capillary density, and structural remodeling, even without weight loss. The scale didn't move, but the fat tissue fundamentally changed. Walking triggers mitochondrial biogenesis in your fat cells. That means your fat tissue grows more mitochondria, the cellular powerhouses that actually burn fat. Research shows exercise increases something called PGC1 alpha, the master regulator of mitochondrial production. And here's the coolest part: walking promotes the browning of white fat cells. You have two types of fat. White fat stores energy. Brown fat burns energy to generate heat. Exercise triggers white fat cells to acquire beige characteristics, more mitochondria, different structure, and expression of UCP1, the protein that lets cells burn fat for heat instead of storing it. The messenger making this happen is irisin, a molecule released from your muscles during exercise. After 10 weeks of regular exercise, plasma irisin levels were 2-fold higher than sedentary controls. Your fat cells are literally becoming better at burning fat just because you walked. But wait, there's more. Walking preferentially targets visceral fat. That's the dangerous belly fat wrapped around your organs that's linked to heart disease, diabetes, and metabolic dysfunction. The mechanism is receptor biology. Visceral fat has 2-fold higher noradrenaline-induced fat release, 50-fold higher sensitivity at beta-3 receptors, and 6-fold higher sensitivity at beta-1 receptors compared to subcutaneous fat. Meanwhile, the fat under your skin has more alpha-2 receptors, which actually inhibit fat breakdown. A 12-week walking study measured changes via CT imaging. Visceral fat dropped 26%. Subcutaneous fat dropped 18%. Walking doesn't target all fat equally. It preferentially attacks the most dangerous deposits. One Japanese study found that every additional 1,000 steps per day corresponded to roughly 4 square centimeters of visceral fat reduction measured by CT scan. Finally, walking transforms your fat tissue from an inflammatory mess into an anti-inflammatory organ. In obesity, fat tissue becomes chronically inflamed. Macrophages can comprise up to 40 to 50% of adipose tissue cells versus around 10% in lean individuals. These immune cells pump out inflammatory signals that contribute to insulin resistance. Regular walking shifts macrophages from the M1 pro-inflammatory type to the M2 anti-inflammatory type. An 8-week low-intensity walking intervention showed 2.1-fold upregulation of anti-inflammatory markers, independent of weight loss. Here's your timeline of changes. Weeks 1 to 4. Metabolic improvements begin. Enhanced insulin sensitivity. PGC1 alpha increases after each session. Weeks 4 to 8. Adipokine changes become measurable. Adiponectin, the good hormone, increases. Weeks 8 to 12. Significant fat loss detectable. Visceral fat shows preferential reduction. Macrophage shift established. Months 3 to 6. Sustained smaller fat cells. Established beige adipocyte population. Waist circumference drops 3 to 5 centimeters. 6 months plus. Long-term remodeling of fat tissue architecture. And here's a bonus finding. Splitting your walks might actually be more effective. A 24-week study comparing 2 25-minute walks daily versus one 50-minute walk found the shorter bout group lost 8.08 kilograms versus 6.39 kilograms, with greater waist circumference reduction. So there you have it. Walking feels easy, but at the molecular level, it's orchestrating a cellular revolution. Catecholamines binding to receptors. The paralipin CGI58 ATGL HSL cascade liberating fatty acids. Cortisol staying low while insulin drops. Mitochondria multiplying. White fat browning. Visceral fat melting. Inflammation cooling. All from a 30-minute walk. Your fat cells had a good run, but their party is officially over. If this video helped you understand why walking is secretly one of the most powerful things you can do for your metabolism, smash that subscribe button. I break down the science behind how your body actually works. No bro science, just research. Subscribe now and I'll see you in the next one.